Hello dear students, here I am Dr. Amjad Ali. In this video we are going to practically conduct the example related to the quantile regression in Eviews, which is given on page number 165 in the Introductory Econometrics for Finance, Chris Brooks book. Okay, for the quantile regression in Eviews, you have to first reopen the CAPM example or the CAPM Eviews data file. So we have to open the CAPM data file. Okay, then we have to click on, so see here some of the commands which Brooks have given, that you have to click on quick estimate equation and then change the method. So here we have to click on quick estimate equation. So here we have to change the method, and here the OLS or simple regression method is given. So here we have to change it with quantile method. So here we have quantile method. So click on the quantile method. So here we get a new window, and this is the same screenshot which Brooks has given on the page number 166. Okay, here we have to select the independent and dependent variable. So we have to write the dependent variable E4 is our dependent variable, and then we type the constant, and then independent variable ER and deep are independent variable are explanatory variable. Okay, here keep it in mind that we have some options here that which can be used to control various set of estimation techniques, but we are here using as a default what is given here. Here you can use the quantile to estimate 0.5%. You can say it 5% level of significance. You can change it with the help of tau value between 0 and 1, whatever the quantile estimate value you can use here. Okay, we are using the default value here, so we have to click on okay. This is the first option for using for selecting the variable option, but here is another method for the selection, that first you have to select the dependent variable and then independent variable, open and press the right click, and then here you have to put the constant in the middle of the variable and then press on quantile regression. So here is the quantile regression. So this is another procedure for selecting the variable. Okay, press on OK. When you press on OK, then this table will be open, and this will shows that we have one dependent variable, and one independent variable. Okay, now we have to use the quantile process or the quantile process coefficient. So we click on view. Here we have quantile process, so we have to click on quantile process. So press OK, and here we have some other options are available that Eview's window give us, that we can use the simultaneous estimates of number of quantiles the default here to estimate the quantile for the data split into 10 segments. So this will give the 10 options for our outcome. The quantile estimation can be displayed here, so you can see that the quantile estimation can be displayed in table and graph at the same time for all of the coefficient for for a specific coefficient, or just we are here the coefficient specifications are also given. We are using the default which is given here, so we have to click on OK. After pressing OK, so this screenshot will be open. This is given on Brooks book page number 167. So this is the same screenshot. So here is the more important that what is the interpretation of this estimates. So here we can say that monotonically the intercept coefficient falls as the quantile increase. So see, as the quantile increases, the coefficient of intercept is increases, and because the data on Y has been arranged in this way. But the slope coefficient, see here, as the quantile increases, the slope coefficient is very more important, that it is very that the first beta is higher than we move towards the higher quantile. So this shows that when we have a lower tail, then our estimate coefficient is much higher. So this shows that the relationship between excess return or dependent variable, excess return, and our Ford stock return for the case of S&P 500 is much stronger when Ford share price are falling. So keep it in mind, when this relationship is going to be more stronger as Ford price are fall sharply. Okay, this is worrying for us. It shows that the tail systematic risk of the stock is greater than for the distribution as a whole. If you are finding the regression in a single coefficient, then then the representation is not showing us that how much quantile distribution is explaining. So whole distribution gives you a single coefficient, single estimated coefficient, but the quantile gives you 9 or 10 different coefficients, and you can make your decision accordingly. Okay, so keep in mind that as the observations as the stock price fall, the benefits, diversification of benefits also fall. So that would be expected from examining only standard regression. So standard regression gives you a only single coefficient, and that coefficient is normally then be overstated. So that's why we have to rely on quantile regression analysis, because it gives you each quantile coefficients. And see here we have explanatory variable in all coefficient, in all quantile. It is highly significant but see here we have intercept and some in few quantile it is insignificant. So this shows that our our beta is highly significant and contributing to our towards our to our dependent variable. Okay, now we have some further testing procedure for the quantile regression analysis. So we have to click on view. So this is the option is given on Brooks book. We have to click on view, quantile process, slope, equality test. So we have to click on view. So here we have quantile process, here we have slope, equality test, and here we have given some option. Here we have to run 10 quantile. It is given on the 4 quantile by default, but we have to write it 10 quantile and click on OK. And don't change anything, but you have to click on option output. So output will give you the first the quantile vector, coefficient matrix or covariance, but we are not changing it here, so you have to click on OK. So after pressing the OK, we get this outcome, and this is, although this is not given in your book, but we are more concerned about the interpretation point of view. So see this output shown that the first as a test of whether the corresponding slope, so corresponding slope, so this is our beta. So corresponding slope coefficient are identical, followed by a pairwise comparison of one quantile with next. So this is given the comparison of one quantile to next, 1, 2 and 2, 3. So see it, when you are comparing 1 and 2, this is the new coefficient. When you are comparing 2 and 3, this is your new coefficient. So this is given the pairwise comparison between one quantile to the next quantile. Result in this case shows that none of the statistics are significant. So see here, none of the statistic or p-value is significant, which indicate that despite the beta estimate differing across the quantile but an economically large magnitude, they are not statistically significant different. So you have to conduct further testing for the solution of this issue, and you have to rely on quantile as a symmetric, and you can change different options here. You can use 4 quantile, or you can graphically check it, or you can here it is slope option. So here we have a quantile option, coefficient process. So here you can use 5 quantile, then you can get the 5 quantile outcome, and for this you have to make the quantile stability test, and then you can use it a 5 because you are using a 5 outcome, so that's why. So the equality slope test will give you the pairwise comparison of the quantile which you have selected. So this is the quantile regression analysis, and I give you once again the overall outcome of the quantile. Okay, we are using 10, so So this is the end of quantile regression. So keep in mind that the quantile regression give you 10 coefficients for the beta and 10 coefficient for the constant or intercept, but simple regression or pair or stepwise regression give you only single coefficient, and that's why simple OLS or simple regression or stepwise regression give you a overstated result, while the quantile regression give you the time to time or quantile based coefficients. So I hope you got it. Okay, see you with other video. Ciao.